Okay, this video is going to be all about finding the area of trapezoids, and I really need you all to get your thinking caps on and make sure you're paying attention and taking notes, because this finding the area of trapezoids is not as self-explanatory as maybe some of the other shapes. First, we need to talk about what is a trapezoid. I have two examples here. A trapezoid has exactly one set of parallel sides. One set of parallel sides. They don't necessarily need to be congruent. So in this shape, these sides are parallel. In this shape, these sides are parallel. Now notice in both shapes they only have one. The other side is not parallel. If the other side was parallel, it would have to be a parallelogram. So a trapezoid has only one set of parallel lines. So now we need to figure out how we're going to find the area of a trapezoid, because that's what the video is called. So here we have our trapezoid A, B, C, D, and we want to find the area, and this is going to be a little bit different. What I want you to remember is your height is not your slant height. This is your slant height. When we're looking to find the height, we need it to make a 90-degree angle from the top to the bottom base. Now, unlike in parallelograms, in trapezoids, your base lengths aren't the same. These are not congruent. They're parallel, but they're not congruent. So we have actually two bases. AB we're going to call base 1, and DC we're going to call base 2. Those have two different lengths. Your height is going to be the perpendicular line, or the line that makes a right angle from base 2 up to the top of base 1. We can put it here, or we can put it on the outside, it doesn't matter. The line AD is not your height, it's your slant height, and that's where you really need to be careful. Here I have my height labeled, and I put my height on the outside. I easily could have had my height on the inside as well, it doesn't matter. My base 1, which we usually use the B with the subscript 1, but we can call it base 1. A lot of people will call this one little b and this one big B. It doesn't matter. Here we have, we could also have our height here, and that wouldn't matter either. You can put your height on both sides. It's really all the same. Anywhere that makes a perpendicular angle or a 90-degree angle from your bottom base up to the top base is fine. These all have the same height. One thing you need to make sure is that your bases, base 1 and base 2, are the lines that are parallel to each other. So regardless if your trapezoid looks like this or if it is at an angle, your base 1 and your base 2 are the lines that are parallel. So now we need to figure out how we're going to figure out how to make the area formula for this. And this doesn't really look like a parallelogram, it doesn't really look like a rectangle, it doesn't really look like a triangle, which are the three things we already know how to do. But I do see, I could make a little line here, and I would then have two triangles. Let's see how that looks. Here I made my line, and you can see I now have two triangles, and I do know how to find the area of my triangles. I'm going to split these guys apart just to make it easier to see. Here I have triangle 1, and here I have triangle 2, so I can find the area of these. Remember, the height from AD and the height from BC are the same height, so both of these triangles have the same height. And if I want to, I can rearrange the triangles. So I just flipped this triangle around to make it a little easier to see. Oops. And now let's see, let's get our triangle areas. Remember, your triangle area is going to be 1/2 of the base of the triangle times the height. And again, you have to make sure that the height is a perpendicular line from the base to your to the top of the triangle. So the area of my first triangle is going to be 1/2 of base 1 times the height, and the area of my second triangle is 1/2 B2 times the height. Remember, both of these triangles put together make my trapezoid. So together I'm going to get 1/2 the base 1 times the height plus 1/2 the base 2 times the height. So here is what we have so far. 1/2 of the base 1 times the height of the trapezoid, which was the same as the height of my first triangle, and then 1/2 the base 2 times the height of my trapezoid, which is again the same as that triangle. So the height for both of these is the same. The bases are different. Now let's see if we can use our algebra to make this look a little bit prettier. I'm going to use what I know about basic algebra to see if I can factor. I noticed that both of my terms have 1/2 and h. So I can factor out the 1/2 and the h from both terms. Factoring out the 1/2 h from each one of my terms, I get 1/2 h times the quantity of the sum of the bases, b1 plus b2. And that's how we're going to find the area. And this is generally how you will see it written. So make sure you have this in your notes. The area of a trapezoid equals 1/2 the height times the sum of the bases. Now let's see if we can use it. Here we have a new trapezoid. Remember, when you're finding the area of a trapezoid, there's a few things you have to remember. Your bases, both B1 and B2, your bases are your parallel lines. So in this case, AD and BC are our parallel lines. So those are our bases. Your height is not your slant height. DC is our slant height. Your height is the perpendicular line from one base to the other base. So in this case, DE. So we just need to use our formula for our area. So what we get is 1/2 our height, which is 9, times the sum of the bases, 10 plus 18. So we're going to go ahead and simplify following our order of operations.